In the previous video, we looked at how vertical asymptotes result from values that make the denominator of a rational expression equal to 0. In this video, we're going to look at how holes in the graph can come about. Holes in the graph result from values that make both the denominator and the numerator equal to 0. So as an example, g of x is equal to x squared plus 2x over x plus 2. If we wanted to simplify this function, we could factor an x out of the numerator, giving us x times x plus 2 over x plus 2, and now cancel or divide out the common x plus 2 factor, giving us x. Now, as we saw before when we were learning how to simplify rational expressions, we have to place the restriction that x cannot be equal to negative 2. So what we're stating here is that the original function g of x is actually equal to simply x, provided that x is not equal to negative 2. Otherwise, whenever x is not equal to negative 2, this complicated function is just equal to x. Now, what actually happens when x is equal to negative 2? Well, it's going to be a hole in the graph. Let's take a look at the graph. So here you can see that this function, it's written here in its factored form, is just equal to the line y equals x. Remember, g of x and y are interchangeable, so we can write y equals x instead of g of x. So this complicated looking function is simply equal to the line y equals x as long as x is not equal to negative 2. When x is equal to negative 2, right over here, we have a hole in the graph. And as you can see from the graph, the y-coordinate there is negative 2 as well. If we wanted to find the y-coordinate algebraically, we would plug the x-coordinate in to our simplified function. Let's take a look now at a table of values to see why that hole comes about. As with when we looked at vertical asymptotes, the table of values here that I've created contains the x-coordinate of the hole, here negative 2, and it's bracketed on either sides by values that get closer and closer to negative 2. First, notice that when x is equal to negative 2, we sub in negative 2 for all the x values, and we end up with 0 over 0, which we call indeterminate, not undefined. Then, if we start from the left-hand side and move in towards x is equal to negative 2, so on the graph, we're starting here and moving in towards negative 2, what we see is that because the same factors are in the numerator and the denominator and will continue to cancel out like this, the numbers don't skyrocket as you get closer and closer to this negative 2 value as they did when we were looking at the vertical asymptote. In fact, as you can see here in this example, they look like they're getting closer and closer to a y value of negative 2 as well. But they'll never get there because of this fact that the values end up becoming 0 over 0 when you would have expected y to be equal to negative 2 right here, just from the graph itself. Same thing happens when you approach from the right-hand side. We're approaching here from the right-hand side, the x values are getting smaller, or getting more and more negative rather, towards x is equal to negative 2. And because factors keep canceling out in the numerator and the denominator, you see that again, the values don't skyrocket. They get closer and closer to a y value of negative 2, but they'll never get there. So holes in graphs result from values that make both the numerator and the denominator equal to 0.